All right, so let's take a look at this serverless quick start example. It's going to walk you through the basics of querying and the computations that we have in the system. So we're going to import a couple packages here, TileDB, NumPy, Pandas, and of course Matplotlib for some nice plotting. Now, the most basic way that you can access the data is simply with our Python API. Very similar to the open source software that many of you guys might have used. You can simply call TileDB.open, pass it a string of the array URI, and then query it with any of our accessors. In this case, I'm going to get it as a pandas data frame returned right here. And so once again, I'm going to use the TileDB URI. I'm not accessing things on the underlying S3 path or Azure Blob Store. Everything's going to go through TileDB Cloud and then shared. And of course, this will work with any of our APIs, R, C++, C#, Java, you name it. In addition to just basic querying though, we also have a number of serverless computations. And these are really where the platform starts to shine, is the ability to take your query or your computation and push it into the service. So here's a basic example of a SQL query. What you want to do here is simply give us the string of the SQL query, and we support full ANSI SQL because we're using our storage engine that we've built with MariaDB on the back end. This query will then be run in TileDB Cloud inside a containerized environment where we run your query in a secure manner. The results then are serialized and returned directly to your client. So you can use any type of SQL query you would expect here. I'm just using a simple extract, but we also support advanced queries. Like I say, it's ANSI SQL, so you could have a common table expression. You could use window functions. You can use aggregations, pretty much anything you name it. You can have parameters. You can do joins if you want it. You have full flexibility in what you do here. And the data that you get back in a number of different capabilities. So first and foremost, you can, of course, get the data back in a pandas data frame in Python. You can also get the data back in Apache Arrow form and JSON. And JSON makes it very easy for you to actually use our serverless SQL queries directly from our JavaScript API, building out websites live from the environment. So when you get into the notebook here, you get a pandas data frame back, and you can plot it. See, and you can do all the visualizations you would like in the environment. Full support for anything you'd like to do. In addition to the serverless SQL, we also have the user-defined functions. User-defined functions allow you to run arbitrary Python or R functions with other language coming up soon in TileDB Cloud. So you simply define a function. In this case, just a simple example, which is going to print hello and then whatever string you pass it. And when you call execute on the UDF, what's actually happening here is we serialize your Python function. We send it to TileDB Cloud. We include any parameters that are needed in the function. And then again, inside a Dockerized, containerized sandbox environment, we run your function, pass in the parameters that it wants, and return your data directly to you here. In this case, you can simply see that hello Seth comes back. I'm using my username here. But this supports any number of parameters and anything you want. The R functionality works very similar. You can define arbitrary functions in R. Arbitrary parameters are supported, can be sent and results returned directly to you. Now, in addition to just arbitrary functions, you can actually also run a function directly on an array itself. So with TileDB Cloud, this allows you to build out and push your computation to the service instead of extracting your data to the client. So in this case, I'm going to have a simple example where I'll take a single array, data going to be shipped in here, but this could also work for multiple arrays. So if you want to do some sort of custom join algorithm or custom linear algebra across different or multiple arrays, you can actually support a UDF on multiple arrays too. And then I'm simply going to return the monthly ridership with a multiplier. Now, when I call apply, same thing happens as before. The function itself is serialized, shipped to the service. Then in the service, everything is run there in a containerized environment. But the important thing to note is when you actually apply it on one or more arrays, we have a lot of optimizations we've done about querying the array in parallel and passing the data directly into the environment to optimize and streamline the latency to actually perform everything in parallel. The results are then returned directly to the user here. So everything happens in as massive parallelization as we can. And we support a number of different APIs and permutations on the APIs in both Python, R, and JavaScript of how you can actually call these functions. So we have a base function where you can pass the URI. We also have an apply function. So no matter what you're familiar with and what ecosystem you're familiar with, we have integrations that look very similar to that. Now, you can also register a function in TileDB Cloud. So besides just running it live and having to carry that definition with you, I could actually register the example function. I'm going to just call it example registration. And then that lets you invoke it by name. So when I invoke it by name, again, we grab the registered code, we bring it into your containerized environment, and then we run it with the results returned directly to you, the user here. So in addition, there we go. And in addition to just the basics of UDFs and serverless SQL, everything can be built up into what we call task graphs. So running arbitrary functions is useful, but most likely you're going to have a complex workflow that you want to build out in the system. So we allow you to handle this directly in TileDB with the task graphs. This allows you to mix arbitrary functions. It could be a SQL parameter, it could be array UDFs, it could even be across languages. If you'd like to mix an R function with a SQL function or R with a Python, all of that's capable. So in this case, I'm going to build out a delayed SQL object. So all of our task graphs work around what we call the delayed APIs. If you've used promises and futures in Python, these are going to work very similar to that. So again, I'm just going to pass it a SQL query because I'm comfortable in SQL. I like to run my queries there. And then I'm also going to define a linear regression that's just going to use SciPy to perform a basic linear regression over the SQL query that I selected. And then I'll return the data directly to me here. So if we visualize this, this is the most basic task graph, just two basic nodes. We're going to run the SQL query and then the linear regression. And when we call compute, what's happening is the SQL query is going to run first, and then the results from that are going to automatically be passed into our linear regression function, and then the results returned here. And if we perform a simple plot, we'll see the nice output of this linear regression. So this is the most basic example, but I think you guys can probably see that the capabilities here are near limitless. So if we actually look at a little more advanced use case, we can build out arbitrarily large task graphs that support any number of direct acyclic graphs. In this case, I'm going to have a large tree of just some arbitrary functions that sleep for this example. And when we run it, once again, by calling compute, everything here is going to be run in parallel. So we can watch the graph update live, and we'll see each stage of the graph run in parallel, and then the computations completely go in synchronous. And when you have a large graph like this, you don't have to worry about what size cluster do I need, what's the environment that needs to be spun up, how many nodes do you need. TileDB Cloud facilitates running everything here. And actually, the graph ran quite quick, so quick that the visualization didn't actually have a chance to run live. We'll show you some other visualizations in a moment. But all of this is handled by TileDB Cloud automatically. So we spin up the cluster, we scale it. We have automatic retry support built into the platform, built into the clients. Different error cases can be handled. If there's not enough resources, things will retry once there is enough resources. So TileDB Cloud facilitates all of the elasticity around the data management aspects. Around the computational aspects, without you having to, again, worry about the cluster or the idle compute that comes with managing large clusters.